And he will show us a guide to software engineering for visually impaired. Please give him a warm welcome.
Thank you, everyone. I was at PyCon last year, and it was such an amazing feeling to meet this awesome people and listen to inspiring talks that I decided to come again this year, but this time as a speaker. So thank you all for coming in, listen to me talk about a guide to software engineering for visually impaired. My name is Abrar Sheikh. I work for Yelp as a software engineer. Yelp's mission is to connect people with great local businesses. It's a search engine for finding the best business around you. I work for the ranking platform team within Yelp, and my team is responsible for building and maintaining search infrastructure and providing search as a platform for other application teams inside Yelp. We leverage technologies like Apache Kafka, Apache Flink, Elasticsearch, and use a lot of Python. I was born with a genetic disorder called albinism, and albinism is mainly characterized by two factors, or like two things. One, severe pigmentation, lack of pigmentation in body that results in discoloration of skin and hair, and severe loss of vision that restricts my ability to do certain daily routine tasks like driving a car or using a computer. As I was growing up, I was extremely fascinated by computers and always wanted to pursue a career in software engineering. And with the right support of my parents, I was able to achieve just that. So today in my presentation, I'm going to talk about some of my journey in software engineering and what are some of the challenges and roadblocks that I hit along the way, and I was able to overcome them. So this is just a concise journey lane of my past experiences. In today's presentation, we'll first understand what low vision really means, how it impacts certain population sets, and what effects it has on the society. What challenges people with low vision face in academia and professional environments, and what are some of the simple strategies using which they can overcome these challenges. Really, my hope today is to convince you all that software engineering as a profession need not be that difficult even for someone with low vision. This chart should be likely familiar to most of you. It's called Snellen's eye chart, and this is what your regular ophthalmologist would use to measure how good your eyesight is. And the metric that we are calculating here is called visual acuity. A visual acuity of 20 by 20 is what is considered to be normal vision. That's on the lower end. And the idea here is that the lower down the chart you're able to read, the better your vision is supposed to be. A vision of 20 by 70 or lower is what can be considered as a low vision, and it becomes worse if you're not able to read anything like from top 3 from the top. But this is not a very accurate representation of what low vision really is. I prefer a more functional definition of low vision, because this might, so the metric of 20 by 70 might not apply universally to everyone, depending on what work they want to do. So a better representation of low vision is really this. It states that uncorrectable vision loss that interferes with one's daily activities, or to put it in simple words, not having enough vision to do whatever it is that you need to do. And this can vary from person to person. For example, a visual acuity of 20 by 70 may be perfectly fine vision to have for someone whose profession is driving, but it might not be sufficient for someone whose profession is a surgeon, for example. So yeah, now that we have a better understanding of what low vision really is, let's look at some statistical data around demographics of US population, specifically for people with low vision. The numbers that I'm going to present to you were published by National Foundation for Blind in the American Community Survey conducted in 2015. About 2.3% of the total US population suffers from some degree of vision loss. And this is a significantly high number, enough that us, like all of us in the tech community, should be responsible for making our software more accessible to everyone. Next, just let's look at some educational data. Around 25, close to 25% of the total US population that suffers from some degree of vision loss drop out before high school, whereas the national average stands at about 6%. Some data on unemployment rate. Around 70% of the total US population that suffers from some degree of vision loss were unemployed in the year 2015, whereas the national average stands at 5%. These are some staggering numbers, and they tend to depict a distinction in our population sets. And the reason why I believe these distinctions exist are for following reasons. Lack of supportive and learning environment in our classrooms. Restrictive access to reading and learning material for students with low vision. Lack of documentation around easy access to technology, and lack of structure and awareness around creating a more inclusive work culture in our professional environments. Throughout my presentation, I'll be touching upon the details of each of these points and try to articulate a plausible solution to overcome these challenges. Next, let's look at some academic challenges that a student with low vision would face. Our education system is centered around classroom learning, and this has been the fundamental way of consuming knowledge for ages now. But the fundamental problem with this system is that for someone with low vision, even with the best optical correction and the proximity to the front of the classroom, it's extremely difficult for them to read contents off of the blackboard or the projector. And all of these factors pose significant roadblocks in terms of attaining a good quality education. Some of the strategies that a student with low vision can apply within their classroom to overcome these challenges are as follows. They can seek help from the student registrar or the student council within the school or university. These bodies within these organized institutions can help facilitate appropriate classroom accommodations, and these can vary broadly based on what condition you have. Some things that have worked for me in the past are extra time during examinations and assignments, seeking help from an assistant who can help take notes during a classroom. Another thing that students with low vision can do is reach out to the faculty or professors within for each lecture and make them aware about their own condition. This way, the professor can help facilitate appropriate classroom accommodations, like getting these students access to previous years' recorded lectures, or even provide them with the lecture notes before every class. This way, the student is more prepared before each class, and the contents within the class are more predictable, and the learning experience becomes just better. Something that has worked for me really well in the past is use of a monocular within a classroom. A monocular is a visual aid device that lets people with low vision see distant, far-off objects. It's kind of like a binocular, but a more portable version of a binocular. People with low vision typically find it extremely challenging to read contents from books and research papers, especially when these materials are not available in larger font, in large font printable formats. One easy solution that can overcome this challenge is with the help of a magnifying glass. Any magnifying glass with an optical zoom of 3x to 5x should sufficiently offset the difficulty in reading. However simple this sounds, this is one of the most often overlooked solutions because it usually takes a lot of time and practice of getting used to. Students with low vision typically find it extremely challenging to get easy access to the contents that are presented on a computer screen. This is significantly more challenging than reading a book, and the primary reason for that is the kind of content which is presented on a computer screen is more dynamic in nature. Just to elaborate, text that is presented on a computer screen rarely follows a prescribed pattern. layout changes drastically between application to application. All of these factors pose a significant challenge for someone with low vision to get to get easy access to the content that is presented on the computer screen. On the other hand, it's kind of hard to imagine a career in software engineering without having easy access to technology. And this is increasingly becoming true for other professions as well in this modern age. Fortunately for us, early developers of operating system have built accessibility as a key focus into their product. Both macOS and Windows ship with great on-screen magnifiers, which help assist students with or people with low vision get easy access to the content that is presented on the computer screen. Just to put things in perspective, I think it's really important to show you what I'm talking about. Like, how does an on-screen magnifier really feels? Like, how does it feel to use it in reality? So I have this web page in front of me, and I know it's kind of hard to read because I've reduced the resolution. And this might be the first time you might actually, like a speaker has actually reduced the resolution so that the audience cannot see the content. But that's on purpose. So yeah, now this is really hard to see. This is exactly how a person with low vision experiences content on the computer. Like, for example, I can tell you offhand that I kind of have an idea of what the layout of this page looks like. Like, there are an array of businesses as form of a list, and there's an image, and then there is some short description. But I don't really have any sense of what content is on there. Like, I cannot really name the name of the exact business that is being presented here. So let's start engaging with the on-screen magnifier and show you how that looks like. So now this is better. As you can see, anything under my cursor is automatically magnified. That gives me a very detailed idea of what that localized area of the screen looks like. Just scanning through the top 3 results, this one looks better because it has like good reviews and good ratings. So this should be a good business. So this was just to show you how someone with low vision engages with an on-screen magnifier to use a computer. Right? If that was kind of hard to imagine, like if you're wondering how I was able to swiftly navigate my way through the screen without actually seeing the content on the screen, let me try to explain that with a driving analogy. Imagine you just moved to Cleveland, Ohio, and you have no idea how the city layout looks like. The only way you're going to get from point A to point B within a city is with a help of a navigation system in your car. Now, a navigation system is really good at giving you a very broad, high-level layout of the city. It tells you what, where what is, but all the while the driver is engaging with the windshield of his car to make those in the moment driving decisions, to look around and to figure out where to take the turn at what exact time. So the on-screen magnifier, which is on the top half of the screen, is really what is the windshield of your car. Try to think of it in that way. And the bottom half of the screen is that navigation system. So a person with low vision does have a clear view of a very localized area of the screen at any given point of time, but all the while engaging with the lower half of the screen to fit that into the broader context of what's really happening what's really happening on the screen at the moment. Cool. Yeah. Next, let's understand what professional challenges exist for someone with low vision. Getting hired, like this is the big one. When I graduated from college and started interviewing for a technical role with companies, one of the biggest challenge I had to fight was with my own insecurities. I would constantly retrospect and analyze my own physical limitations and conclude that there is no way any company is going to hire me. And I think to small or large degree, we all find ourselves in this situation. The next time you find yourself in this situation, I want you to remember the following. All your hiring manager really cares about is the answer to the following 3 questions about the candidate. Does the candidate have exceptional analytical and problem-solving skills? Does he or she have the right leadership skills to drive business value to the company? And are they a strong team player? However simple this sounds, in reality, your physical limitation should have no correlation to your ability to perform these job requirements. At the same time, it's kind of hard to, at the same time, if you do need certain accommodations, as part of your hiring process, do not hesitate to bring that up with the recruiter. After having spoken to a lot of recruiters myself, one thing I can say with confidence is that your physical limitation should have no impact on the hiring decision that is being made. It only depends on how good of a candidate you are, like what kind of skills you bring to the table. But if you are a recruiter looking to hire an engineer with a certain physical disability or low vision to be specific, here is a word of advice for you. Ask the candidate if they need extra time as part of the hiring process. Second, and this is the most important one, make sure all the interview questions are being all the discussions and the interview process are carried out on a whiteboard or a computer of the candidate's choice. The second one is particularly important, and I'll touch upon this briefly in the next slide. Being successful in a career for someone with low vision takes a lot of self-drive and self-initiative, but at the same time, it's also a community effort and support. So here are a few ways in which your peers can help you. As a manager, you can help provide appropriate workspace accommodations, and these accommodations can change or depend from person to person. A few things that my manager does for me, which I've found extremely helpful, are he ensures that I have a desk away from windows or sunlight, because brightly lit environment make up for a very difficult working experience and extremely challenging. He ensures that I have access to the slide deck before every team meeting. This is particularly important because it's not always the case that I have visual access to the contents that are presented on the projector or the computer screen. So next, if for example, if you're on a team and you're working on a problem with a fellow engineer who suffers from low vision, for example, ensure that all the discussions are carried out on a whiteboard, and the context around the problem is shared on tickets and documents. Try not to engage in pair programming, and the reason for that is engineers with low vision have a certain way of using their computers with all the accessibility features turned on, like the one I showed you. So they're seamless at their work when they're particularly on their own, they're doing work on their own computer, but not so much when they're working on someone else's computer. As a tech community, we should strive for consistent coding standards, have high amount of documentation and code coverage in our code. This is important, other than the obvious reasons. This is particularly important in the context of this discussion, is because for someone with normal vision, he or she can read about 10 lines of code without moving a visual muscle. But for someone with low vision, they can only read about 3 lines of code in the same amount of time. So that's an inefficiency of about 3x. So anything that we can do to make their experience better and make them more efficient is worthwhile. Just to put some context and show you what I'm talking about. This is a piece of code taken from the Avro library, and I know this is hard to read, but that's again on purpose. So we're looking at this function. Let's try to look at this with like the normal zoom. So you see, when you're looking at this function, you're constantly scanning back and forth. Like the details of this function are not important. When you're looking at this piece of code, you're constantly scanning back and forth between those lines, trying to make sense of what's going on. But remember, you have the context of, so when you're looking at this function, you're looking at this function as a whole. But for someone with low vision, this is how it looks like, right? When you're trying to read this code, you're only scanning about 3 lines of code at a time. So going through this function 3 lines at a time and then back again is time consuming. And the point that I'm trying to make here is if this function has a good documentation, then all it takes is one linear scan of reading through that documentation and trying to get a sense of what's going on here. So the better the documentation, the better the reading experience becomes. Just to recap everything that we've discussed so far, here are my top 3 recommendations for someone with low vision trying to be successful in a career of say, software engineering. The first things first, gather all your tool sets, and these tools can vary from person to person. Some of the tools that we discussed during this presentation are use of a magnifying glass to get access to books and reading materials, use of a monocular to get access to classroom, and use of an on-screen magnifier to get access to computers and technology. Now, once you have your tool set ready, spend enough time and practice your skills with those tools so that you become as efficient as a person with normal vision. And this typically takes a long time. So the sooner you start, the better, the more efficient you become over time, and the better that will be in your subsequent career. Lastly, but the most important one is do not hesitate to ask for help. It's in your best interest to make sure your teammates are aware about your condition so that they can step in and help you whenever necessary. Just to finish this off, I think I showed you how I use the computer, but I think it's important to show you how I actually code, which is a slightly different experience than like reading stuff. So for the demo, we're just going to write up a simple binary search function. Right? And I want you to be focused on the top half of the screen. And I know you can't read the lower half of the screen, so that works. So as you can see, as I'm typing along, I'm moving the cursor with me so that I have the context of what is that I'm typing. This is the worst binary search ever. Two. Cheat a little bit. Yeah. Let's throw a print statement there. And let's assert if that really works. Cool. Let's see if that works. Cool, it works. So yeah, that should give you some sense of how I use the on-screen magnifier to read and write code. Yeah, that's all I had for today. Finally, Yeah, as I said, I work for Yelp. We are an awesome team. I highly encourage you to come check out our booth on the exhibition hall. And please read through our engineering blog posts. They're awesome. We write a ton of good technical and non-technical content like this. Yeah, thank you.
Thank you, Abra. So we have time for questions. You can find the microphones in the back.
Hey, thanks for your talk. I was noticing that when you were using the magnifier, you had to keep scrolling the mouse cursor down so you could see where you're going.
Mm-hmm.
Would it make sense for the magnifier to follow the cursor?
Yes, for sure. And I think I typically like such IDEs, but for the demo, I was using Sublime, which doesn't have that for some reason. But IDEs like Visual Studio do that, and that's extremely helpful.
Okay, cool. Thanks.
So again, thanks for your talk. I noticed when you're using the magnifier, it really like blows up the text that you're looking at, and it can be kind of blurry. It seems like you're looking at a old school, super low resolution video or something like that.
Right.
So how important is it as when you're developing products with accessibility in mind, is the overall resolution of the visuals so that you can see, like, is there a specific sort of density that's recommended for visually impaired users so they can use the magnifier effectively?
Yeah, that's a great question. And I think my comment on that would be, this has definitely gotten better over time. And I think it looks a little more pixelated now just because I've reduced the resolution here. So if I take this to the normal resolution and try to apply the zoom now, like this looks much better than what I showed you before. So yes, it definitely helps to create those front-end objects with like high amount of pixel, but yeah, I don't really have an exact number in mind.
Thank you.
Thank you for your talk. A similar question, but targeted to developers. As a developer, what would you want to change in terms of linting or style guides that would address something that would make it easier for you to read as a low vision reader? For example, like there's a tension of the size of how descriptive a variable is versus how much of your visual field it's going to take up, or things like that.
Yeah, I think all the standards that we've already established in PEP, which is, hey, do not exceed 80 lines within like 80 characters within a line, keep your function to about 10 or 12 lines, have documentation, document your arguments, are all the stuff. If we did follow them consistently, I think that'd be a great first step. On the tooling front, one package that I really recommend, or tool that I really recommend for especially Python projects, is this project called Precommit, which basically runs your linter and fixes the code and ensures that the entire repository is in one consistent style. So as long as that's taken care of, I think that is a sufficient good step.
Does your toolkit also include screen readers?
Not me specifically. So screen readers are definitely a tool that a blind person using a computer would use. For me, I haven't found it, like I found my efficiency to be much better, like just with the on-screen magnifier. But yeah, for people who have extremely bad vision, at which point the on-screen magnifier is not helpful, a screen reader is definitely a good option.
Thank you.
Hi, I'm curious on your workflow. Do you work with a lot with data with charge, or with some visual element?
Right. So my workflow is typically either like one of those, like one of the two. Most of my time is spent on Bash shell because I'm an infrastructure engineer. I'm mostly doing like log analysis, looking at logs on Bash. Also spend a lot of time writing code in IDEs like Sublime or IntelliJ. Those are the two main ones that I spend the most time on. Yeah. But looking at logs is difficult. I think that's a good point. Logs is definitely difficult to scan, specifically if you're using an on-screen magnifier. Just to go through all the logs is kind of hard. So I usually end up writing scripts to like do that work for me, so that I'm only looking at subset of the logs, or looking at those logs in Splunk. So yeah. If a normal engineer is just making sense of logs just by looking at the raw logs, I typically take that extra effort to load it into Splunk so that I have a better visualization and I'm not missing any tiny details.
Second question, I'm curious on any particular elements that difficult for your magnifying class to work with. For example, does your magnifying class work with a pop-up tool where you hover your mouse over and then the pop-up was way over another size?
For sure. Everywhere. Like that's a feature I've given up on. Like stuff like Amazon, right? Like you hover over a product and it gives you this pop-up. I can never get to the pop-up because by the time I move to the pop-up, it's gone. So yeah. So in circumstances where I know that there is no alternative way of like reading, like to get out, like to get rid of the pop-up, there is another version of this on-screen magnifier which lets you magnify the entire screen and not just the one specific segment of the screen. So that variation of the on-screen magnifier really helps with the pop-up.
Okay, thanks again, Abrar. Please give him another round of applause.
Thanks.